Thanks, Nicole.
Thank you. Thank you for coming so numerous. I'll have to be a bit fast because I realize I have more slides and more things to say than the half an hour I asked for. So I apologize for being a bit quick. My name is Nicola Musatti. Here you have a few contact information. What I'm going to talk about, why we're here, what I mean by making Python a better scripting language, handling commands, handling interpreters. The difference for me is non-interactive and interactive programs. Sort of conclusion, and hopefully some time for question and answers. So, what is a scripting language? A scripting language is a sort of programming language, usually simpler, has, however, some form of flow control, some statements, and most of all, it provides a convenient way to execute commands. The purpose of a scripting language is to, the original purpose is to make it possible to write a sequence of commands to be executed automatically. Is Python a scripting language? Oh, great topic for flame wars. And it is obviously a programming language that has very many flow control statements. But in my opinion, it provides a not so convenient way to execute commands. And I'll show you what I mean by that. Just about any common interpreter, even the old DOS, you just write your command and it executes. In Python, there are different ways, but at the very least, you have to import a module that provides the plumbing for executing external commands and write something like that. What I find problematic, what I don't like, is the fact that at this point the command is in a string, so it's not a semantic element of my language, Python in this case. So the common Python approach is okay if you have not necessarily simple but fixed command lines. But when you start dealing with complex command lines, when you have to build your command line with complex logic, the fact that you are actually composing a string and the meaning is actually lost inside the string is not very convenient. And the language is not supporting in that. And for these reasons, it's not very easy to come out with really reusable code. So here's an example of what in shell is a simple script, but not a simple command by my standards. Just create a subversion repository. If it succeeds, I'll fill it up and then check out the contents. And this is what the same would appear in Python by just using subprocess. It's not terribly complicated, but I don't like the fact that the most important behavior, it's embedded in strings. One possible theoretical approach is to augment Python with the capabilities of a typical shell by making it possible to call programs directly from Python. There have been attempts at writing Python shells. I don't like this approach, not for programming, not for scripting, because I don't like the way different syntaxes that are used differently are mixed up. Ideally, it would be something that feels natural in Python, like to run ls, just say import ls and print ls with your options specified as arguments. So let's see how I dealt with this. This is what I want to do. In terms of, when you look at it, it's not so different from my example, except for small but what I feel are important things. What I want to do is to make sure that I can create a repo by specifying a function call, a method call, and then, of course, the path is an argument, and it's reasonably to have it in a string. In the same way, if I want to create directories inside my repository, I use a function call with arguments specified directly and options specified as keyword arguments. So my nxpy command package provide means to specify to wrap commands so that you can express them as method or function calls, express their arguments as function arguments, and express options as keyword arguments. As you shall see in a few seconds, it provides ways to specify declaratively the types of options that are supported by your implementation. Makes it possible to express constraints or option and argument combinations. So you can't use this option if you have arguments, or you need to specify arguments for that options and things like that. Builds command lines and executes them and returns the command's output and error. Then it's up to you to decide what to do with the output or error of your command and what you want to provide back to the user of the library that you're writing. And as I said, it can be used both with non-interactive and interactive commands. It is most effective when you're dealing with complex commands that have many subcommands and many options. While I know there are different subversion APIs, it's a very good example because it has very many commands and a very wide option set, and options are shared among different commands. This is the structure of my package, and I'll just explain what's inside. So this is the kind of options that you can specify. Boolean options, where it's just as the ones you would write directly on the command line to have an effect. Other options can take one or several arguments. There's a way to specify that an option has to be written on the command line with a specific syntax by using a format string. You can map options that are expressed in one way within the program so that they are mapped to a different syntax on the command line. And it's possible to specify options that you have to put on the command line when they are false. Sometimes this is convenient if you want to write a wrapper that uses an opposite default from what your command actually provides. This is how you would write that for my subversion example. And you can specify a non-default prefix for options, or that option arguments are separated by a different character than just space. There are commands that use commas to separate the arguments to options. This is an example of how you would implement the import subversion subcommand by using a parser class. I call it parser because in my view it parses the argument and keyword arguments it passes to the method that you're using to wrap your command, and from those it synthesizes that portion of the command line. You specify actually the options that are supported by that command by indicating them as keyword arguments with a default value. That not only says how they are to be put in the command line if they are not specified explicitly, but also that these options, like message here, are supported by this command and not others. And I use a command class that just expects to use a parser class to pick up the information and actually implements the real function call, the common execution actually. That non-argument stands for a debug argument. When it's not, when it's true, commands are echoed rather than executed. I found this a convenient way to debug or to test or pre-test shell scripts, and I put the same thing inside my library. When you have commands that have a non-reversible effect, sometimes it's convenient to first see how the command line comes out before trying them out. And this is how you could write the ls example that I showed before, by configuring options, Boolean options, all and long, so that if they are true, they are to be put on the command line, and they are actually mapped as -a or -l. If you didn't map them, they would come out as --all --long. In this case, it may not be important, but there are commands that use a dash inside the option name, which would make them invalid Python identifiers. So let's see now how we can handle interpreters. The option handling and command line forming part is done in the same way. And I use non-blocking I/O to ensure that I never deadlock between writing to the command and getting its output or error back. However, this makes it complicated to identify when the current command has been fully completed. Because, when you are actually running an external command, you have the exit code, and you know that once you get that, the command has terminated. In this case, in output and error are open streams, and when you read from them, you might get that there's nothing available, but the read operation returns immediately, and so you have no way to decide. You have to actually check the output to find a way to identify the ending. What I do is I periodically poll the output and error to check for termination. Sometimes it's convenient to decide to abort a command that's running for a long time. This is an example I'm just going to run through very quickly. This is for the clear tool, which is the command line tool for clear case, which is another version control tool. In this case, I was lucky because by issuing the minus status option, clear tool issues this string at the end of every command. So it was easy in this case for me to find out when the command was completed. This is how I would implement the actually execution of commands. What I do is I use a regex to identify the end, which is the one I showed before, and inside my interpreter class, there's a loop which checks every now and again whether this string has come out in the output. If you're not that lucky, you have to find ways, and sometimes each command that you are wrapping needs different handling. And I called waiters the tools I provide to check for the end of the execution. Either it may be enough to just find that there's been output or error, or you can check that the output is a certain number of lines, whether there's a specific string or a regular expression. This is a different example. As I said, this is a wrapper for the FTP command. Again, there are libraries, and when there are libraries, it's certainly more convenient to use them. But when it's, again, a convenient example. In this case, I define a single open command for opening the connection and logging in. And in this case, I had to check after each subcommand that the output contained, for instance, the return code that's issued by FTP after every command. But in some cases, this was not enough because, for instance, the FTP command issues the password prompt on standard error. So to enter the password at the right time, I had to check for that, and only at the end, check for the last success message. I provide ways to control the polling algorithm by specifying a timeout, a number of retries before you decide that you want to abort, or that how often you perform these retries. For instance, for the update command for clear tool can take very long, and in this case I used a timeout of 300 seconds to be checked every half second. So I'll try to wrap up, hopefully leaving a little time for some questions. As I said, if there are APIs, it's much more convenient to use them. Python is not a scripting language. It's much more, and it's usually much more convenient to use it fully than to just wrap commands, which are still a bit awkward to handle. But in some cases, the command line interface can be more stable than an API. You can avoid problems of finding the right version of the bindings, or compiling the bindings and things like that. And sometimes, as it was my case with ClearTool, there isn't an API, so I had no other option than to do something like this. Just a couple of pieces of advice. I find it more clear to implement each command on its own rather than trying to compress the code and have a more complex reasoning, because in that way it's easier to see what you are implementing, the relationship between the API that you're building and the actual command that you are going to issue. Again, it's very easy to miss the end of the output and so go into an infinite loop polling for something that actually has already happened. And remember that some commands you can't really recover from, and before issuing them, ensure that you know what you're doing. there are the classical problems. I was a bit ashamed of coming here with a library that doesn't work with Python 3, but then I read a long Twitter thread by Armin Ronacher complaining about the problems he faced in implementing his click library for the how hard it is to work with encodings, especially on Linux, and finding the right encoding. And so his final advice was, if you can, stick to Python 2, and that's what I did. So this is the URL for the library. It's on SourceForge, not on GitHub. I'm an old chap. I started putting open source stuff on the web when GitHub wasn't there yet, and it's available from PyPy. These are the tools I used for the presentation. If you have any questions.
So, any question? I actually have a very quick question. How does nxpy compare with the sh module, which does a very similar thing? I see that nxpy is actually more configurable than sh, but one strong compelling reason to use sh is that it's a single file, so that I don't have to ask my users to actually use pip to install a package. I can just slap sh.py next to my script and I can run it. So I was wondering if there's a one file implementation of nxpy.command. So
no, I had thought about that, but there are small pieces I use here and there that are in different modules, so it wouldn't be very convenient to put it in there. For instance, I'm using an old Python cookbook recipe for non-blocking I/O, which is in its own module, which I took from that website, and so it wouldn't be very convenient. I would say this approach is reasonable if you have to use not only a very complex command, but also use it extensively. Otherwise, probably more agile solutions can be better. Another thing I wanted to say, you may have noticed some similarities, especially in the FTP example with the pexpect module. I originally thought of using that, but I was working on Windows, and pexpect actually is only working on POSIX, as it uses pseudo terminals directly, and I couldn't use that.
Okay. So any more questions?
This is your last chance, because in about 5 minutes I'll be leaving from the hotel to catch my train, so I won't be around for chatting about this, unfortunately.
Okay, I guess we are done. Okay, thank you, Nicola.
Thank you.
I'd like to invite Joel on stage.